What if, by the end of this decade, we could turn science fiction into everyday reality? What if a kid born today could grow up in a world with near limitless clean energy, organs healed by regenerative medicine, and quantum networks rewriting how we connect? Faster than ever, safer than ever. Over the next few minutes, I'm going to walk you through 7 scientific breakthroughs that could change everything. Not in maybe 50 years, but possibly by 2030. Breakthrough hashtag 1 Fusion Energy Coming of Age. Think about the energy we use today: coal, gas, nuclear fission, even renewables. What if we had a source that's clean, abundant, and as powerful as the sun? That's the promise of fusion energy. In a fusion reactor, light atomic nuclei, like hydrogen isotopes, merge under extreme heat and pressure. In doing so, they release enormous energy. Unlike fossil fuels, it doesn't produce long-lived radioactive waste. Unlike fission, there's no risk of runaway chain reactions. Recently, some experimental reactors have reported energy outputs that get close or even exceed the energy put in, a major milestone for fusion research. If scientists succeed in scaling this up, we could build power plants the size of office buildings that provide enough electricity for entire cities. Imagine cities powered by clean fusion, vastly reduced electricity costs, no carbon emissions, and enough energy to run power-hungry infrastructure. AI data centers, desalination plants, space missions, even terraforming ambition. Of course, there are big challenges ahead. It's one thing to make a small reactor work in a lab, another to build and maintain huge infrastructure. Materials that can withstand extreme temperatures, magnetic fields, costs of construction, and regulatory, political, economic hurdles remain. So while optimism is high, we should expect realistic timelines, late 2020s to early 2030s for commercial viability. If fusion lives up to the hype, it could solve our energy crisis, but the gap between lab success and powering entire cities is still big. Let's move to another field where breakthroughs are already underway. Breakthrough number 2, regenerative and personalized medicine, growing organs and healing from within. What if, instead of waiting for organ donors, we could just grow a new organ, tailored to your body? That's becoming more realistic thanks to advances in regenerative medicine, stem cell research, and bioengineering. Scientists are experimenting with lab-grown tissues and organs. Some are already promising. The idea is to use your own cells to print or grow new organs or tissues, reducing rejection risk and potentially curing previously terminal conditions. Beyond organs, personalized medicine powered by genomics and molecular biology means treatments tailored to your own DNA. Imagine therapies custom designed for your risk profile. Fewer side effects, better effectiveness. Diseases that today require lifelong treatment could become manageable or even curable. Real-world implications: longevity increases, better quality of life, less strain on healthcare systems. Transplants could become routine, chronic diseases could often be prevented. Still, this isn't magic. Growing fully functional organs is complicated. Vascularization, integration with the body's systems, immune response, long-term stability, clinical trials, regulation, ethical questions. But by 2030, we might begin seeing real results for some organs or tissues. Maybe skin, liver patches, maybe kidneys. Breakthrough number 3, quantum computing and quantum internet, a new era of computing power and secure data. Right now, the computers we use, even powerful data center servers, operate using bits, 0 or 1. But quantum computers use qubits, which can be 0 and 1 at the same time, superposition, and leverage entanglement, allowing operations that classical computers cannot handle efficiently. What does that mean? For certain tasks, like simulating molecules for new drugs, optimizing complex supply chains, decrypting or encrypting vast data, or running AI models, quantum computers could outperform today's supercomputers by orders of magnitude. Beyond computing, a quantum internet could make data transmission fundamentally more secure, tapping into quantum entanglement and quantum key distribution to make eavesdropping nearly impossible. For you, that might mean faster drug discovery, breakthroughs in material science, supercharged AI, personal data protection taken to a new level, maybe even secure global communication networks immune to hacking. Of course, quantum tech is still fragile. The qubits today are easily disturbed by environmental noise. Error correction remains challenging. Building large-scale quantum networks is non-trivial. So while 2030 might see early commercial quantum services, full-scale quantum internet might take longer.
Breakthrough #4. Advanced materials and nanotechnology. Stronger, lighter, smarter stuff. What if buildings, cars, or devices could be made from materials thousands of times stronger than steel, yet lighter than aluminum, or materials that self-repair when damaged? Advances in nanotechnology, metamaterials, and material science are pushing boundaries. Smart materials could self-heal small cracks, reduce weight, increase durability. Graphene-based composites, new ceramics, carbon nanotube frameworks, these could reshape manufacturing, construction, transportation, electronics. Implications: lighter, more efficient vehicles, safer, longer-lasting buildings, electronics that are more durable or flexible, wearables integrated more naturally, maybe even clothing that adjusts to temperature or environment. Challenges: scaling production from lab to mass manufacturing, cost, ensuring safety and environmental impact, regulatory approval. But by 2030, we might see mainstream applications, aerospace components, smarter infrastructure, high-performance electronics. Breakthrough #5. AI-powered climate and environmental science, from prediction to action. Climate change isn't waiting, but now science and AI are joining forces. In 2025, major advances show how AI can massively improve atmospheric science, environmental monitoring, and ecosystem management. Scientists propose using machine learning to analyze vast climate data, predict extreme weather, optimize resource use, and even monitor ecosystems, like oceans, forests, at previously impossible scales. What this means? Better weather and disaster predictions, improved early warning systems, smarter allocation of resources, real-time monitoring of environmental damage, perhaps more effective interventions to curb pollution or biodiversity loss. For regular people, more accurate forecasts, less surprise floods, heat waves, storms, safer cities, smarter agriculture, maybe even cleaner air and water. For humanity, a better chance to mitigate climate change and preserve ecosystems. Of course, this depends on data, quality, coverage, ethical data collection, plus infrastructure to act on insights. And AI models can be wrong or biased, especially in unpredictable systems like climate. So it's a powerful tool, but not a magic wand. Breakthrough #6. Brain-machine interfaces and neurotechnology, merging mind and machine. Picture controlling machines with your thoughts, not science fiction anymore. Research into brain-machine interfaces, neural implants, and neural technology is advancing fast. The idea? Translate brain signals into digital commands, interpret neural patterns, maybe even read or stimulate memory, senses, or mood. Potential applications: restoring mobility to paralyzed patients, giving control to prosthetics, treating neurological disorders like Parkinson's, epilepsy, maybe enhancing cognitive abilities. Imagine someone with a prosthetic hand that responds just like a natural one, or people communicating silently by thought to text or augmented senses. But this terrain raises deep ethical and safety questions: privacy of thoughts, mental autonomy, long-term effects on brain health. Technically, interpreting brain signals reliably is extremely hard. Consistency, longevity, safety remain unresolved. By 2030, maybe early clinical use for medical rehab or therapy. Full-blown human-machine merging remains speculative. Breakthrough #7. Space exploration, Moon and Mars missions, and commercial space infrastructure. Space used to be for superpowers and few elite missions, but now, with increasing interest, private companies, and renewed international efforts, space exploration is entering a new era. By 2030, we might see sustainable lunar bases, Mars mission preparations, asteroid mining prospects, and broader commercial space infrastructure. Why this matters? Earth is fragile. Off-world bases mean resources, expansion, insurance against global catastrophes. For science, study of other worlds, geology, climate, maybe even life science. For humanity, new frontiers, jobs, technologies, bigger perspective. Plus, some of the advanced materials, AI, robotics, energy breakthroughs described before will enable this push. But space remains harsh. Cosmic radiation, long travel, massive costs, political or geopolitical hurdles, long timescales. So by 2030, expect initial steps, moon bases maybe, robotic missions, infrastructure building, but not full Mars colonies yet.
Putting it all together, why this mix of advances means 2030 could feel like the future. If fusion gives us near-limitless clean energy, regenerative medicine extends healthy lifespans, quantum computing and material science unlock new capabilities, AI helps us fight climate change, neurotech expands human potential, and space becomes more accessible, then the world we know could transform radically. It's not guaranteed all will succeed, and not all will be ready by 2030. But combining these technologies together could reshape society, economy, health, environment, maybe more than anything in the last century. So what can you do now? Keep informed, support science, stay curious, because each major breakthrough we discussed isn't just for scientists, it's for every one of us, maybe even for you. If you enjoyed this ride into the near future, hit like, subscribe for more science explorations, and comment below which breakthrough do you think will have the biggest impact on your life? Or which one scares you the most? I'd love to know.